Okay, this follows up with the previous video, which was making a decision tree and finding out how that corresponded to the two-dimensional plane we were visualizing with the iris data. The purpose of this is to talk about, once we have a tree, how to get rules from it. So this is still chapter 3 stuff from the textbook. The direction we're going right now, which is from a tree to rules, is in general easier than taking rules and building a tree. Which is not something we have to worry about too much, but just because of the material in chapter 3, it's something that we see. So the way we want to think about this, or the way the book describes it for us, is that if we have a leaf on the tree, then what that means is there's going to be a rule corresponding to that leaf. So that's only true when the leaves are actually classifying things. Sometimes leaves can be null, and in that case the book draws them as triangles, but we don't have to deal with that in this tree. And so what we can do is we can look right here. For instance, we see that, okay, setosa happens whenever our y value happens to be less than 0.6. And so there we have a leaf, and the way we find the rule for it is we have to figure out the path from the root of the tree to the leaf. So in this case, it was just that this is true, that y is less than 0.6. So we end up writing down a rule like, if y is less than 0.6, then, I'm not going to write the then in the interest of space, but that's what this is really all about. And then our book would also write this class is equal to setosa, but in the interest of space, once again, I'm not going to write class equals either. So if y is less than 0.6, we have setosa. And the good thing about that is when we've dealt with this leaf, we actually got rid of, in some sense, half of the decision tree. And so then we can do that for the other leaves as well. And the reason I'm really erasing that, aside from illustrating we got rid of it, is so that I have a little more room to draw rules. And so then if we find another leaf right here, we have to do the same thing. We have to find the path back up to the root. This one's more complicated because it's 2 levels down. And so the textbook tells us something in that case, that what's going on is we can think of this as an implicit and. And so basically what that means is that we know, okay, in this case, something is fulfilled, that our y value is not less than 0.6, or in other words, not less is another way of saying greater than or equal. And so then we also know that this happens to be true. So also know is the same thing as we can say, oh, that's and. And so in this case, once again, it's something not fulfilled. We're testing y less than or equal to 1.7. That's not true. So that's the same as y greater than 1.7. And so then in that case, the class is versicolor. And so we can do this till the cows come home. Once again, we've gotten rid of another leaf on our tree. I can kind of take it off the diagram so we don't have to deal with it anymore. So what's going on here is that all of these leaves we're being able to turn into decisions, into rules. The problem is this is actually not a particularly good rule. If we look at this and we say, okay, well, what's going to be the case when both of these are true? Well, if they're both true, y is greater than or equal to 0.6 and it's greater than 1.7. So this rule we got with implicit and is kind of stupid, because this first part is completely unnecessary. We only need the last one. And so whenever you make rules from decision trees like this, you end up with really complicated stuff in general. And so there's a process where what you do is you actually prune the rules that you get. And in this case, we eliminate things that are redundant. And so we end up with this simpler rule when we do that. So we could keep on doing this. I'm only going to do one more, and then that'll be the end of this video. So I'll pick a leaf here. And so now it's 3 levels down. We get the implicit and. And so what we end up with is, okay, the first condition was not satisfied, so we can write that rule as if y is greater than or equal to 0.6. The second one is satisfied, so another condition, we add an and. Y is less than 1.7. The third condition is also satisfied, so then another and for that condition. X is less than or equal to 4.5. Then the class, in this case, is versicolor. And so what we want to do at this point is we want to look at this rule and we want to say, okay, can we simplify this any? And in this case, no, we have two comparisons on the same variable, but one's a greater than or equal, one's a less than or equal. And so this rule is as good as it gets. So if we wanted to keep doing this, we would recognize that we have two more leaves left. They're even further down the tree, so we would have 3 ands. We would have 4 tests in our if statement, and then we would be done with the classification. But this is the general procedure. This is how we take a decision tree and convert it into rules. So basically, if we want to summarize, every leaf that classifies becomes a rule. And then as we find the path from the root to the leaf, then what we need to do is we do that implicit and. And so we have to and all the conditions that the leaf satisfies together. And so the only trick with that is that when a leaf is on a false part of a branch, then we have to take the opposite of the condition. And so what that means is sometimes that negation of the decision rules will have to happen. So if we wanted to write this as some kind of pseudocode or just a procedure we could follow, that's what we ended up doing. And with that, I'm just going to kind of make a low sort of white noise as I finish up writing here. Okay, so we're finished.